The edges of our solar system, once thought to be unreachable, were visited by two spacecraft that became part of the history of global space exploration. 1977, Cape Canaveral, Florida, two Titan 3 Centaur rockets provided the power needed to launch one of the most important missions in the history of astronomy, the Voyager program. They are nearly identical in design, but as you'll see, they followed very different paths and missions. One of the most remarkable things about these probes is that even after nearly 50 years since their launch, they are still operating, drifting through space, though with limited functionality. The Voyagers witnessed some truly incredible sights. But what exactly did they see? This video will follow a timeline so you can understand in detail everything that was discovered along the way, including the moment when the probes crossed the boundary of our solar system. Let's get started. This is where our timeline begins, but still without the probes. Back when the program was first being developed in the 1970s, no one could have imagined that these two spacecraft would still be functioning nearly 50 years after launch. To give you an idea of how limited space technology was at the time, no exoplanets, planets outside our solar system, had been confirmed yet. Even so, Voyager 1 and Voyager 2 not only achieved the mission's goals, they went far beyond them. In the 1970s, the Voyager spacecraft were being prepared. At that time, the project focused on solving the main problems the probes might face in space. One of those problems was solved with a very clever solution, one that became essential to the success of the entire mission. For a mission exploring the solar system with the technology available at the time, it was crucial for each Voyager probe to use as little fuel as possible. In the late 1970s, the solar system seemed to be perfectly aligned for human exploration. A rare alignment of Jupiter, Saturn, Uranus, and Neptune was occurring once every 176 years, allowing for a unique opportunity to hop from one planet to another using gravity assist. It was far more cost-effective to send a set of probes during this rare alignment window, rather than launching individual probes to each of the planets.
2, 1, we have ignition and we have liftoff.
Voyager 2 launched first on August 20th, 1977, followed by Voyager 1 2 weeks later. This image of the Earth, the first of its kind ever taken by a spacecraft, was recorded on September 18th, 1977 by Voyager 1, when it was 7.25 million miles from Earth. The Moon is at the top of the picture and beyond the Earth as viewed by Voyager. Almost 3 months later, as it entered the asteroid belt, Voyager 1, despite launching after Voyager 2, followed a faster trajectory and overtook Voyager 2 on December 15th, 1977, traveling at approximately 10.6 miles per second. Then, in March 19th, 1979, Voyager 1 reached the Jovian system, Jupiter and its dozens of moons. Both Voyager spacecraft were specifically designed and shielded to withstand the intense radiation they would encounter while passing by Jupiter. This was achieved by carefully selecting radiation-hardened components and protecting the most sensitive parts of the spacecraft. An unprotected human aboard Voyager 1 during its encounter with Jupiter would have received a radiation dose equivalent to 1,000 times the lethal level. The spacecraft made its closest approach to Jupiter on March 5th, 1979, flying about 217,000 miles from the planet's center. To understand just how close that is, consider that the Moon is on an average 238,600 miles away from Earth. Voyager 1 sent back the first close-up images of Jupiter's swirling clouds and its famous Great Red Spot, a colossal storm larger than Earth. Voyager 1 also discovered a thin ring around Jupiter and 2 new Jovian moons. In addition, Voyager 1 sent back detailed images of Jupiter's 4 large Galilean moons, Io, Europa, Ganymede, and Callisto, as well as Amalthea. The discovery of ongoing volcanic activity on the moon, Io, was probably the greatest surprise. Io was filled with active volcanoes spewing lava hundreds of miles into space. This was the first time volcanic activity had ever been observed beyond Earth. Then, after a little more than a month of observations, it was time for the spacecraft to set its sights on Saturn. The gravitational assist trajectories at Jupiter were successfully carried out by both Voyagers, and the two spacecraft went on to visit Saturn and its system of moons and rings. Voyager 1 encountered Saturn in November 1980. Voyager 1 found that about 7% of the volume of Saturn's upper atmosphere is helium, while almost all the rest is hydrogen. The images they returned of Saturn's rings were incredible. Trillions of pieces of ice, from tiny grains to chunks the size of cars, move along these rings. Their movement is controlled by the gravity of Saturn, its many moons, smaller moonlets, and even nearby ring particles. At Saturn, Voyager 1 discovered 5 new moons and a previously unknown ring named the G ring. The spacecraft also observed wind speeds of up to 1,100 miles per hour, and accurately measured the planet's rotation period as 10 hours and 39.4 minutes. And now, one of the most anticipated moments for scientists, Voyager 1 arrived at Titan, Saturn's largest moon, passing just 4,019 miles away. Images of Titan revealed a thick atmosphere that completely hid the surface. The spacecraft discovered that Titan's atmosphere is made up of about 90% nitrogen. The presence of nitrogen, methane, and more complex hydrocarbons suggests that prebiotic chemical reactions might be possible on Titan. To some scientists, Titan, with its nitrogen-rich atmosphere, looked like a primitive Earth whose evolution may have been frozen long ago by a kind of ice age, possibly preserving organic materials beneath its current surface. Voyager 1 was ending its planetary science mission because Titan was considered a top priority. Voyager 1 trajectory was carefully planned for an ideal flyby, which took it below Saturn's south pole, sending it out of the plane of the planet. As a result, Voyager 1 would not visit Uranus and Neptune. The mission team could have adjusted its path to escape Titan and sent it to Pluto instead, but that option was never taken. Now it was time for Voyager 2 to continue the journey. 4.5 years after leaving Saturn in 1986, Voyager 2 became the first and only spacecraft to visit Uranus. There, it encountered a strange tilted world. Uranus rotates on its side, likely due to a massive collision early in its history. It also has a surprisingly strong magnetic field that's tilted far off its rotational axis. Voyager 2 discovered 2 previously unknown rings around Uranus. These rings are quite different from those found around Jupiter and Saturn. Scientists believe the rings of Uranus may be relatively young, not formed alongside the planet itself. The particles making up the rings could be remnants of a moon that was either shattered by a high-speed impact or pulled apart by tidal forces. Voyager 2 also sent back spectacular images of 5 of its largest moons: Oberon, Ariel, Umbriel, Titania, and Miranda. Close-up images of Miranda revealed massive canyons and fault systems. One theory suggests that Miranda may have been shattered by a violent impact, then later reassembled from its own debris. After a month of studying Uranus and its moons, Voyager 2 set its course for the final planet on its journey. In 1989, Voyager 2 reached Neptune. That same year, it became the only spacecraft ever to visit both Uranus and Neptune. During its Neptune flyby, Voyager 2 passed just 3,000 miles above the cloud tops, the closest approach of any planetary flyby in its mission. The probe revealed that Neptune is a planet of extreme weather, with the fastest winds in the solar system reaching up to 1,300 miles per hour. It also discovered the giant storm system known as the Great Dark Spot. Voyager 2 also discovered 6 new moons: Proteus, Larissa, Despina, Galatea, Thalassa, and Naiad, along with 4 new rings. It photographed 2/3 of Neptune's largest moon, Triton, revealing the coldest known object in the solar system and signs of icy nitrogen volcanoes on its surface. The Neptune flyby marked the end of Voyager 2's planetary encounters, closing an extraordinary 12-year tour of the solar system. After passing through the Neptune system, Voyager 2 followed a course below the ecliptic plane and headed out of the solar system. At that point, Voyager 2's instruments were switched to low-power mode to conserve energy, and NASA officially renamed the entire project the Voyager Interstellar Mission. And what about Voyager 1? Where was it at this point? After Voyager 2's long journey through the last 2 unexplored planets, on February 14, 1990, one of the most iconic photographs in the history of astronomy was taken. The scientist Carl Sagan proposed the idea that the space probe should take one last photograph of Earth. He acknowledged that the image wouldn't offer much scientific value, since Earth would appear too small for Voyager's cameras to capture any detail, but believed it would hold deep symbolic meaning, offering a humbling perspective of humanity's place in the vast universe, seen from about 3.7 billion miles away, beyond Neptune's orbit. Earth appears in this image as a tiny dot suspended in the darkness of space. This iconic photo became known as the pale blue dot. Now, after completing their missions successfully, both Voyager probes continued their journey towards the edges of the solar system, achieving important milestones in astronomy. In February 1998, Voyager 1 overtook Pioneer 10 to become the most distant spacecraft from the Sun, at 6.4 billion miles. From that moment on, one of NASA's main interests was to find out what the solar system is like beyond the heliosphere. In December 2004, Voyager 1 crossed the termination shock, the point where the solar wind slows to subsonic speeds, and entered the helioheath, where the solar wind is compressed and becomes turbulent as it interacts with the interstellar medium. On December 10, 2007, Voyager 2 also reached the termination shock about 1 billion miles closer to the Sun than Voyager 1 crossed it, indicating that the solar system is asymmetrical. In 2011, data from the Voyagers revealed that the helioheath wasn't smooth, but instead filled with giant magnetic bubbles thought to form as the Sun's magnetic field twisted at the edge of the solar system. By June 2012, NASA scientists reported that Voyager 1 was very close to entering interstellar space, indicated by a sharp increase in high-energy particles from outside the solar system. And then finally, on August 25, 2012, Voyager 1 crossed the heliopause as officially announced by NASA in 2013, becoming the first spacecraft to enter interstellar space. Voyager 2 would cross the heliopause later at the end of 2018. Today, both Voyager 1 and Voyager 2 continue to travel through interstellar space billions of miles from Earth. For centuries, astronomers have debated where the solar system truly ends. The generally accepted scientific boundary is where the Sun's gravity no longer dominates, beyond the planets and the Oort cloud. This boundary lies roughly halfway to the nearest star. Traveling at speeds greater than 34,800 miles per hour, the Voyagers will take almost 40,000 years to reach this boundary. All of this means that while the Voyager probes are in interstellar space, they have not yet crossed the final edge of the solar system. And the chief scientist who led the Voyager program for 50 years, Professor Edward Stone, confirmed it. He has always been careful not to use the exact phrase "leave the solar system" when referring to the spacecraft. Even though they are far from this boundary, The probes continue to send back precious data even as their power fades. Cosmic rays, magnetic field changes, and plasma waves helps us understand what lies between the stars. The Voyager probes will eventually cease to function, primarily due to their declining power supply generated by radioisotope thermoelectric generators. These generators use radioactive material, specifically plutonium-238, to produce electricity. As the plutonium decays, the power output decreases, and eventually there won't be enough power to operate the spacecraft. If it weren't for this, the Voyager probes could continue transmitting information to Earth for another 1 or even 2 centuries. Even so, there is still one final mission. Each of the Voyagers carries a message for potential extraterrestrials in the form of a 12-inch gold-plated copper disc. The Voyager Golden Record has symbols showing Earth's location in relation to several pulsars. The disc includes instructions for how to play it, similar to a vinyl record. The disc's audio includes greetings in 55 languages, 35 sounds from life on Earth, and 90 minutes of music from Mozart to Bach. It also features 115 images of life on Earth and recorded greetings from then US President Jimmy Carter and then UN Secretary General Kurt Waldheim. In the vastness of space, the Voyagers are like tiny bottles floating in a cosmic ocean, carrying a piece of who you are. They are more than just machines, they're symbols of human curiosity and our desire to explore the unknown. For more videos like this, subscribe to the channel. See you next time.